So here we have an air track glider that is attached to a spring, and the glider is pulled to the right and released from rest at 0 seconds. It then oscillates with a period of 2 seconds and a maximum speed of 40 centimeters per second. So what is the amplitude of the oscillation? Well, we know that the period is 2 seconds over here, so we know that. This is our d. And we know that our maximum speed is 40 centimeters per second, so we can mark that down as V max. All right, so question A, we know from the equations we derived in class that V max is equal to 2 pi FA. And we also know that F is equal to 1 over T, so we can just substitute that into the equation and get 2 pi A over T. Now we know A, we want to know A, and we know V max, and we know T, so we can just rearrange this equation and we do some algebra, and we get that A is equal to V max T over 2 pi. And then that this is equal to 40 times T, which should be 2, and all over 2 pi. And if we plug that into our calculator, it turns out that we get 13 centimeters. And remember, this is in centimeters because our initial speed here, Vmax, was 40 centimeters per second. So we have to make sure that we keep the unit as it was given to us. Next, in question B, we have what is the glider's position at t equals 0.25 seconds. Well, for this one, we can just use another equation given to us on the equation sheet. X is equal to A cosine 2 pi f t. Now we know that our A, or amplitude, is 13 centimeters, or 0.13 meters. We don't have to put it in meters first, but for the sake of argument, let's put it in meters. Just why not? Then cosine 2 pi. And then remember from before that f is equal to 1 over t. So we replace this with 1 over 2 as our frequency. And we have our t, which is 0.25 seconds. And if we do the math on this, it turns out that we get 0.09 meters. And that's all there is to it.